We're trying to find the velocity equation, which is the derivative of the height equation. So for the height for A, it's negative 5x squared plus 20x. To take the derivative, you take the coefficient times the exponent and drop the exponent, which I got negative 10x. Take the coefficient times the exponent, drop the exponent, and I got 20. So for the velocity of 24, it is the derivative of h of x equals negative 10x plus 20. For B, they were asking how fast the book was going at time x equals 3, and was it traveling up or down. So I plugged in 3 to the derivative function, which I got negative 10 times 3 plus 20, so I got negative 10 meters per second. The book was going down at x equals 3 because the velocity was negative, and I got the velocity of negative 10 meters per second. So the height at h of x was decreasing. For C, they asked at time x equals 3, was the book above or below where Chuck threw it, and how far? So I plugged in 3 for the height, and I got negative 5 times 3 squared plus 20 times 3, and I got 15 meters. So the book was 15 meters above where he threw it because there was no C variable in the height equation, which if there was a C variable, that would equal the initial height. But since there was none, that was 0 meters, so at 0 meters, it was when we was thrown. So there is a 15 meter difference, so therefore it's 15 meters above where he threw it. And lastly, at D, they were asking what time was the book at its highest point, and how do you know? So at the highest point, that's when the velocity will equal 0. So I plugged 0 into the velocity equation as the y value, and I got 0 equals 10x plus 20. So then I just took simple algebra, and I did negative 20 as the y coefficient equals 10x, and then divided by 10 and got x equals 2 seconds. So therefore, at x equals 2 seconds, the book will be at highest point.